Okay, so this is a more advanced story. Now we've got two matrices. Before we had a matrix and a vector, or a vector and a matrix, right? So row vector times matrix. In the preceding video, a matrix times vector. So now we're going to think about a general product and see what's a useful way to break this down. There are lots of ways to break these kinds of multiplications down, but here are two general ones. So we can go in this direction. We can keep A intact, and we can see B as by its column vectors. So again, asterisk indicates we run over the indices here. So this is the first column. So it's the first column. And then we'd go 1, 2, 3, 4, 5 down to M. When we multiply A in, if we think about how the dot product rule works, then what results in this first column is A times B1. Right? So the important thing here that you see is that these columns don't end up in B1, right? There's none of the values of this part of the matrix end up here. So the first column of C, right, this thing we're trying to multiply A and B together to get, the first column, it depends on all the values of A, right, that's the whole matrix A, and just the first column of B. Similarly, the second column, just the second column of B, and then all of the values of A are involved. So this is just the peculiarity of matrices. On the other side, if we can break it down into rows, right, because it's always a row dot column. That's how matrix multiplication is built out of. We could take the rows here. So again, first row, second row, mth row, and then we take all of the values across here. Let's indicate these times B. So we're going to break it in that way. And then when we multiply in, I'm just kind of giving you this here. This will be this row vector times B, the second row vector times B, the mth row vector times B. Each one of these is a 1 by n. B is n by k, and so the result is a 1 by k. So we have a 1 by k row vector, 1 by k row vector, 1 by k row vector. They all, you stack them on top of each other and we get C. So here's an example. It's an example we did in class. We did, of course, the standard multiplication, dot products, dot products, dot products. It's going to end up as a 2 by 3. But in some cases, it's, again, useful to go through this larger procedure. So we can see this, the first column of C only depending on the first column of B multiplied by A. And then similarly, we get this. It's just the second column of B multiplied by A. For children screaming, ignore that. And if we go in this direction, we're going to take each row of A, 1 minus 2, 2, and then we take all of B, 2, 1, 0, 2. So the first row only depends on the first row of A, all of B. Again here, all of B. So let's figure this one out. So we can take this, and you could play around with this as well, but this is really adding up all of these rows here, right? So we're going to combine all of those rows. That's a good way to think of it, just as we did in the previous video. So 3 times minus 1, 0, 0 times 2, 1, 2, 0, 2. All right. However you want to think about that. So this is going to be, let's make it look like this. It's going to be a stack of 2 row vectors, right? So we get a minus 3. 3, there's a 3 zeros, so this is a 4. This way, we're going to get minus 1, minus 4, and then a 0. So this is minus 5. And then we're going to get 1, minus 2, plus 4, so that's 2. So this equals, and we've created these row vectors, but we can think about this now again as a 2 by 2. Good. And this way, we've got ABs everywhere, right? So we're going to combine all of those columns, and these are the weights for it. So let's make it a pair of column vectors. Adding these things up. So we get minus 3, 0, 2, minus 3. There's a minus 1, minus 2. So again, we get that minus 5 business. And over here, 3, 0, 2, so we end up with a 4, 1, minus 2, plus 2 is 2. Sorry, minus 2 plus 4 is 2. So this is the same thing. All right, so that's another more powerful way to manipulate wrangle products into something that you can then do something theoretically with.